right?
Yeah, it's 9.
Yeah,
Yeah.
so welcome everyone to the sixth NSF PIRE PDC workshop and also the second workshop that is being organized in conjunction with NatCom Combat. I'm the principal investigator on this National Science Foundation Partnerships for International Research and Education project. This year we have the a workshop endorsed by the American Ceramic Society. So some of you already, actually most of you already know this because I talked about in our last meeting. This is the Partnerships for International Research and Education project. And so both research and education aspects are critical. And the whole idea here was to sort of jumpstart PDC research in US academia, which has been lagging behind Europe and Japan. So we're dealing with all the aspects of PDCs, preparation of pre-ceramic polymers, understanding polymer to ceramic conversion processes, and then eventually utilizing pre-ceramic polymers for making fibers, CMCs, and measuring certain, thermal, mechanical, chemical properties. So we have three research thrust areas. We also have 3 education themes. And so the idea here is to reach out to our friends across the Atlantic and gain expertise in processing of pre-ceramic polymers, especially those that are amenable to fiber drawing, fiber drawing. And so we are looking at binary, ternary, quaternary PDCs. We have partners from Germany, Professor Ralph Fiedel, from France and then Italy as well, with unique expertise. So, for example, Professor Ralph Fiedel here expertise in chemistry of polymers, and then Professor Crystal Gervais with expertise in NMR of PDCs. So this kind of expertise is lacking in the US, and from the US side, we have expertise in the ceramic side of things, measurement of certain high temperature properties, and also CMCs. So this slide here, you may have seen at least some of it in the past. So these are some of the themes that we have pursued in the past 5 to 6 years. This is a 5-year project. We are already in the 6th year, as it's called the extension year. And so our initial focus, as I mentioned to you, was on just simply learning how to prepare these pre-ceramic polymers and characterize these pre-ceramic polymers in at university, the partner university. So that was our initial focus. And then in the first year, we were able to draw fibers from certain pre-ceramic polymers by interfacing with organic polymers, simply by hand spinning. So, and then later on, gradually, we moved toward preparation of fiber mats by use of electrospinning. So here we are looking at cyclic siloxanes that are low cost and available in the US. So we would make non-woven fiber mats of silicon oxycarbide ceramic. And then gradually we looked at other oligomers. These are linear siloxanes. And these were relatively easy to spun into fiber form. And they would also generate silicon oxycarbide ceramic, which was comparable to the silicon oxycarbide that is prepared through cyclic siloxane. And then in the last year, we started looking at other aspects involving PDCs, because there's some evidence in literature that introduction of nanoscale fillers into PDC may lead to improved sort of like mechanical properties or certain multifunctional properties depending on the type of filler that you're using. So here we are exfoliating materials, for example, graphene or MOS2 into pre-ceramic polymer and monochrome fiber. Early this year, it's we have increased collaboration with industry now, which is more interested in ceramic matrix composite, interfacial coatings, for example. So here we have been looking at more complex PDCs, hafnium containing SiCN, tantalum containing SiCN, SiOC, and their processing and then use as a coating material, as a matrix material. and also high temperature calorimetry involving metal containing PDC. So these are the students who worked in my lab in the last year or so. Shakir has graduated. He is now a postdoc continuing in my lab. He works on HFC ceramics now. And then Sanjay is a graduate student who will finish his degree this year. He is the one involved in exfoliation of 2D materials and tuning the rheology of pre-ceramic polymers by introduction of nanoscale fillers. And then Lokesh was a PhD student visiting my lab from IIT Madras. And then Eloisa, the student who was co-mentored by Professor Gunther Motz. And she's originally from Brazil. She has also finished her degree involved in fiber spinning. And then Jerson is a student from Arizona State University who works on high temperature calorimetry. And Joe Garcia is a student at Lehigh University. So these students are not here, so I'll briefly talk about their research. You will hear about Shakir's research and Sanjay's research in tomorrow's presentation. And Jerson is presently at Los Alamos, so for the entire summer. And then Joel is visiting Air Force Research Lab. So as I mentioned, this is not your typical research project. So this has a strong education component attached to it, which means mentoring of undergraduate students, and then introduction of courses related to PDC materials. So these are some of the undergrads who worked with me in the last year. Muhammad is involved with CMC processing. He is presently in Arizona, presenting his research at one of the defense conferences. These four students, they are interning. Presently, Phillips 66, which is oil and gas company in Texas. Allison is with Boeing. She's working on composite in Washington. Caitlin is interning for Burns and Max in Kansas City. And then we have a new student, Bailey, who is interning for Collins Aerospace. And these students worked on various aspects of PDCs, pre-ceramic polymers, and also layer by layer coating for CMCs. So this is the program. So you will hear about Shakir, Sanjay, and Mohammed. These are students who are not able to get visa, so they will be presenting their research over Zoom. And then we also have Takaya, and over there, she's a graduate student with Peter Kroll, and then Spencer, who is a graduate student with David Marshall. So I have one slide on Gerson's research. It's not here. So he is, as I mentioned, a graduate student with Alex Navrotsky at Arizona State. So this is a student who was visiting my lab, and he learned about processing of PDCs. We took 4 commercially available siloxanes, and we paralyzed them at different temperatures, 1200, 1300, 1400, for example. And then you would take these samples back and perform high temperature calorimetry, which is happens to be their expertise. And then that allows you to calculate or to measure the enthalpy of formation per gram of the PDC material. However, if you're interested in enthalpy of formation per mole of the material, you need to know the composition, elemental composition. So traditionally, scientists have utilized bulk combustion analysis to obtain composition, chemical composition. And that's generally time consuming and it's quite expensive. It may cost you upward of $6,000 for 3 or 4 samples. So here what we interested in was, we said, okay, can we utilize something like, for example, XPS, which is a surface analysis technique, and then obtain composition from that. And then, and see what kind of numbers we get, use the composition for XPS. And what we realized was that the enthalpy of formation used per mole with composition measured using XPS was not very different from that obtained through bulk analysis, especially for samples that were processed at 1200 or higher. So this is a big, it's an important observation because that saves us time and money. So this is the paper that is that came out early this year from Lokesh, who was a visiting student in my lab. So Lokesh works for Ravi Kumar at IIT Madras, and their group has pioneered preparation of PDC, especially quaternary type. And so they have developed this kind of a precursor, single source precursor that would result in titanium containing silicon oxycarbide. And so they were looking for a use of this material for energy application. So they are looking at some capacitor applications and also batteries. So the student would prepare these samples at different temperatures. So we assisted with the SEM and the PM. And then those are the results as electrode for lithium-ion battery. What we found was that the silicon oxycarbide that was containing titanium showed improved rate capability and capacity retention compared to neat SiC. This is another paper that came out this year, June actually. So this is Eloisa's work. So she conducted this research at University of Wyoming. So she would take siloxane, which are very difficult to spin compared to siloxane, at least that has been our observation. So she would do the spinning in air versus spinning in nitrogen. So in air with 60% relative humidity, and what we are and the pyrolysis done in nitrogen. What we noticed was that the fibers that were produced in air, the spinning done in air, were considerably thinner compared to fibers produced in nitrogen and mud. In fact, those produced in air were average diameter of 800 nanometers. Those produced in nitrogen, those produced in air were thinner. So those are 100 and 135 nanometers. Those produced in nitrogen were 800 nanometers. And then we utilized these materials for battery application. What we found was that those that were processed in air, of course, they were oxygen containing. They were SiCNO composition. They showed higher capacity, but huge higher hysteresis as well. So this is lithium going in, lithium coming out, and so this is the charge capacity. So those that were containing oxygen showed higher capacity, but also higher the voltage distribution, which is the energy inefficient. But those that were processed in nitrogen, they showed improved rate capability. These are some of the other papers that related to PDC that came out from our group in this year. This includes, I don't have the time to talk about all of this, but one of which is the provisional patent. These are some of the research presentations given by graduate students. So we have about 25 from this funding cycle. These are select 13. So I'll just talk briefly about broader impacts. This is an important aspect of any project funded through National Science Foundation. So we're basically looking at, how does this research benefit society? So which could be, just promoting these materials to broader scientific community or commercialization aspects. So this is these are two examples of how we introduce PDC research into classroom teaching. So we introduced two projects. This is a course listed here. This is a course that ME575, which is required for all mechanical engineering students in their final semester. So these are two projects that were developed in collaboration with industry. One sponsored by Honeywell, other sponsored by Spirit Aerosystems. So here the students designed this kind of a test jig for 3-point bend testing of CMC mini composite. This one is a test jig that the students designed for measuring the interlaminar tensile strength of CMC. And of course, workshop is part of the broader impacts because we are promoting PDC material. And so last workshop was organized here and we had approximately 50 attendees, if I'm not mistaken. So how do we measure the success of the workshop? I think one way to do that would be through qualitative surveys, right? So this is the result from the surveys, assuming that everybody answered honestly. So you can see that the graph is shifting to the right and up. So what you have here is, so this is, you neither agree or disagree, agree, strongly agree, for example. That's the question we ask. So what, the important one here is this, orange one, which says that the workshop promoted face-to-face interactions. It's the most important aspect as far as NSF is concerned. Um, this is a slide I just added a couple of days ago. So someone asked us like how many of our undergraduate students end up pursuing ended up going into industry versus those decided to pursue PhD. And we know that this is a difficult call. You know, not many students want to pursue. That's such a long term. So here are some students, except for Suzanne, one student. All these are students who worked with us as an undergrad and then decided to pursue our master's degree with either with us or at another institute. And you can see here with Peter Kroll, there's a lot of Peter Kroll here. Uh, so these are so that's one way to measure success. So another thing is, how do we promote PDCs, to broader scientific community? We do that by organizing tracks or symposiums at established conferences, or by organizing workshops or standalone events. So we did that this year as well. So I'll just present three examples here. So this is the MSc. So here we partnered with Professor Ralph Peters, Sanjay Mathur, and this was mostly this was a hybrid meeting. And then this event here, ISIEM, I serve on the International Advisory Board with Samuel here. This was last week, so it was last week. Uh, and then this another one. This one is in September. This is organized by Samuel, and I happen to be on the International Advisory Board with Ravi Kumar. But they're still accepting aspects. If you're interested, please apply. So last but not the least, I would like to thank, we have many special people here, but two I would like to mention in particular, Crystal Gervais, who has been with us since 2018 and also before that, but with PIRE since 2018. You have hosted students from our group, and we work with you on NMR of PDC materials. And then Crystal has assisted us with hosting of undergraduate students related to additive manufacturing. And then we also have Dr. Mike Sinivert, who has been our partner from Air Force Research Lab. This is the second time you're attending the workshop, if I'm not mistaken.
I've attended others virtually.
Yeah, other virtual, yeah. And then you have hosted, two of our students have worked with Air Force Research Lab. And then we have a new and upcoming star, Professor Nicholas Bedford, who is obviously well established in as far as nanomaterials and catalysis research is concerned, but you have interest in 3DC materials. So you're joining us from New South Wales, Australia. So this is the program. I just want to mention that we will have a longer break here. So after Peter's talk, Professor Gianlo Serrano, he couldn't make it. We had some surgery scheduled and leave. And so we don't have anybody here. And then after the lunch here, we have one presentation at 1:35. So this presentation at 1:15, I believe, has been moved to tomorrow. So we have one speaker from GE who will be joining us from this schedule. So it's 5:30 in the morning over there. So we cannot move it here. It's not possible. So we will, yeah. You can watch it it's over the Zoom. So you can be in this room or you can watch it somewhere else. So with this, I would like to thank the National Science Foundation for funding this research. But more importantly, Professor Ralph Friedel, who has provided us with this, international visibility. So you can't do this kind of events without having someone, you need someone, some big name or someone with just credentials, someone who's internationally known. So thank you, Professor Riddle, for your support. So who's next?
Sure.